Curtis Sparling is our final guest on this show, and I gotta tell you, what he brought with him will just roll your socks up and down. It's good to have you with us, my friend.
Of course. It's
And
glad.
you and I wanted to tell the folks at home what you teach here, but it's such an elongated. What do you teach here?
So I'm an assistant professor at Rogers State University. I'm also the department head of technology and justice studies. And I teach cybersecurity, network administration, and UAS technologies. And I'm going to say drones for the layperson kind of thought out there.
I warned you, check your socks. They may be rolling up and down even as we speak. You brought some things with you. Could you explain them? And let's start on the low end and bring it forward.
Absolutely. So what I brought with us today, and I'm going to go ahead and lean forward and hand some of the things to you. So what I have initially is one of our mini drones. And Sam, what we do is I bring a bunch of cybersecurity, network administration, and drone students together, and we do community outreach in Northeast Oklahoma. And that takes the form of middle school students and high school students. We'll bring them on campus, and we'll teach them how to do 3D modeling, 3D printing, soldering, some basic electrical engineering, basic aeronautics, and teach them how to fly a drone. And part of that process...
Can we get a shot of what he's holding, or do we need to move it? Yeah, there we go.
Part of that process is them actually designing a drone body. So what I have in my hands is an actual drone body and drone that a fifth grader from Northeast Oklahoma designed and ultimately ended up building.
A fifth grader?
That's right. So again, we take them through 3D modeling, and you would be surprised how quickly the younger students simply gravitate towards and have a fantastic time designing.
Is this the next one up?
It is. It is.
Is it okay for me to pick it up?
Absolutely. So that is another drone body, similar age group to where a student designed that. In truth, we have not gotten that one to fly, although it looks fantastic. It functions more as a car. And what that did, Sam, I do not mind students not necessarily meeting their ultimate goal, because that particular one was an opportunity to talk about functions of flight, basic aeronautics, and why that particular one didn't fly based off of thrust, pitch, roll, and power going into each of the motors.
So they can learn from their mistakes.
That's what we do all the time in that kind of applied learning.
We have a piece over here. It's a silver drone.
It
has a bit of a Star Wars look to it.
It does, and that one was designed actually by a high school student, and that is a mock-up of the Millennium Falcon. I'm a big Star Wars fan myself, and quite frankly, that's my favorite one that's been designed.
Does it work?
It does work, but what we had to do was add additional batteries, put those in series in order for it to get enough thrust off of the propellers to bring it up.
Son of a gun.
Yet again, it was another opportunity to have a deeper discussion on what we were doing inside the classroom.
We're slowly working our way up to the top dog on the table. We'll get to that first. But in the floor is one that has a pretty solid homemade look to it.
It does indeed. And that one was made by my students, university level students. And what they did with that one, they decided that they did not want to expend any funds. They didn't want a 3D model. They didn't want a 3D print. They wanted to come up with materials to build a drone that was found. So the foam pieces that you see on that, that's actually refrigerator foam that they got from a salvage yard.
You're kidding.
No, they went out, busted up a refrigerator, took the foam out of it, and they actually used some of the glass reinforced plastic from the side of the refrigerator, built a second drone body out of that. In this one, they used the refrigerator foam, obviously, and then found a yardstick out there. So the yardstick was perfect for them to be able to get the spacing requirements that they needed for the thrust of the aircraft. So that one they made from pieces off of a salvage yard, less the electrical component.
So it can be done.
It can be done, and we've used the heck out of that particular drone, because what we ultimately ended up doing was mounting it to a PVC pipe with a base and a top. And we take that out to different events spreading STEM awareness. You notice there's a hole drilled in the top of that one, and that allows individuals to fly that particular drone that sounds like a small jet aircraft safely in an enclosed environment. And so they're able to adjust pitch and roll while the drone is on a stick, and we have dubbed it drone on a stick. Right?
Curtis, we're fast running out of time. We have
I'm
about
so
3.5
sorry.
minutes. Let's get a shot of the other one that has a glass top on it that's also on the floor. Is that student made?
That one is made by my students also. It has 34 distinct 3D printed components on it that they engineered off the top of their head. I don't know if you can absolutely see the name of that particular drone. I dubbed it over-engineered when I saw the time and effort that they put into that drone body. Flies like a champ, but oh my goodness, did they put some time into that.
Now, on the table is the monster.
Yes.
Explain to us in short order, what have you got there?
So this particular drone is a DJI product, and we use that.
What does that mean?
That is just a company that manufactures drones. This particular drone, we would not possess the capability in my maker's space to make it, based off of the capabilities simply within it. And with this particular drone, we're able to do GPS 3D mapping down to the centimeter. So when my students, once they get through this particular process of the design, build, and fly, it quickly goes into data collection. So we are not taking this drone out, having a good time on the sticks, taking pictures, doing that, anything like that. We are setting this up as a data collection tool. So we will fly this between 60 and 90 minutes, collecting data on a specific terrain, think construction company.
Well, that could also be used by law enforcement, couldn't it?
Oh, it absolutely can. And I'm glad you brought that up. Rogers County Sheriff's Office is going to come out and receive some training on this drone, because it also possesses FLIR capability, infrared capability. So there are tactical uses for that, as well as first responder rescue uses.
Curtis, we got about 1 minute left.
Ooh, I've talked a lot.
I know, but you've said so much and you've given us so much. I'd love the opportunity to watch this one work, the big one on the table.
For sure.
So perhaps we can get together and you can put on a demonstration.
I would love to put on a demonstration and put you on the sticks and see what that drone can do.
You think I won't do that? I'll show you.
I'll get you behind it. I
All
promise.
right. Curtis, we're out of time. Thank you, buddy.
Thank you.
Appreciate it. Thank you for joining us at home, and we'll see you again next time.